Our planet, Earth, travels through a vast and sometimes busy cosmos. Space is filled with rocks of all sizes, from tiny pebbles to enormous asteroids. When one of these space rocks, called a meteoroid, survives its fiery journey through our atmosphere and strikes the ground, it becomes a meteorite. The force of this impact is truly immense. It releases a tremendous amount of energy, far greater than any conventional explosion we can create. This energy vaporizes the meteorite and a large amount of the ground it hits, blasting a huge bowl-shaped hole into the surface. This scar on the landscape is what we call an impact crater. These events are powerful shapers of planetary surfaces. We can see them clearly on the Moon, where there is no weather to erode them away. Here on Earth, processes like wind, rain, and the slow movement of tectonic plates work tirelessly to erase these ancient marks. Yet, some are so large, so profound, that their ghostly outlines remain even after millions or even billions of years. Studying these craters gives us a window into our planet's violent past. They are geological storybooks, telling us about the immense forces that have shaped the world we know today, reminding us that our planet is part of a much larger, dynamic universe. The formation of a crater is a dramatic and near instantaneous event. In a fraction of a second, solid rock behaves like liquid, splashing outwards from the point of impact. The intense pressure and heat can melt the rock, creating unique minerals and formations that scientists can identify millions of years later. The initial deep bowl is often unstable. The walls can slump inwards, and the compressed rock at the center can rebound, sometimes forming a central peak or a series of rings. This complex structure is a telltale sign of a large impact, helping geologists distinguish these craters from other geological features like volcanoes. It is a humbling thought that our planet has been struck by these cosmic projectiles throughout its history. Each crater tells a story of a specific moment in time, a day of unimaginable destruction that nevertheless contributed to the ongoing geological evolution of Earth. Some of these impacts were so powerful they altered the climate and influenced the course of life itself. Understanding how these craters are made is the first step in reading their incredible stories and appreciating the long and often turbulent history of our home world. A history written not just in rock, but in the scars left by visitors from outer space. The largest impact structure ever found on Earth is not hidden in a remote desert or deep beneath the ocean. Its remnants lie in plain sight in South Africa. It is called the Vredefort Crater. What we see today is not a simple bowl, but the deeply eroded remains of a colossal impact structure. The original crater has long since weathered away, but what is left is a massive multi-ringed system. The most visible feature is the Vredefort Dome, a ring of hills near the center of the impact zone. This dome itself is about 70 kilometers across, but it is only the central uplift of a much larger structure. When scientists piece together all the geological evidence, they estimate that the original crater was truly gigantic. The initial diameter was likely between 250 and 300 kilometers, or about 155 to 185 miles. This makes it the undisputed champion, the largest single impact event that we have found evidence for on our planet. To imagine its scale, think of a city like London. You could fit the entire sprawling metropolis inside the Vredefort Dome alone, with room to spare. The full crater would have covered an area larger than some small countries. It is a feature of almost unimaginable size, a testament to a truly cataclysmic day in Earth's deep past. The asteroid that created this enormous scar must have been a monster. Scientists estimate it was between 10 and 15 kilometers wide, a mountain-sized rock falling from the sky. The impact would have been apocalyptic, releasing energy thousands of times greater than all the world's nuclear weapons combined. It would have vaporized vast swathes of the landscape, triggered earthquakes that shook the entire planet, and thrown unimaginable quantities of dust and gas into the atmosphere. The effects would have been global, a profound shock to the planet's systems and any life that existed at the time. This monumental event did not happen recently. Geological dating of the rocks melted by the impact tells us that the Vredefort asteroid struck our planet an astonishing 2 billion years ago. This was long before the age of dinosaurs, long before complex animals or even plants had appeared on land. The world was a very different place, inhabited mostly by simple single-celled organisms in the oceans. While the impact must have had a devastating effect on the global environment at the time, its story is not one of dinosaurs. It is a much older, more ancient tale from a chapter of Earth's history we are still working to understand. Now, let us turn our attention to another famous impact structure, one that holds a very special place in our planet's history. This is the crater linked to one of the most dramatic events in the story of life, the extinction of the dinosaurs. This crater is named Chicxulub, after a nearby town in Mexico. Unlike Vredefort, the Chicxulub Crater is not easy to see. It is buried beneath a kilometer of younger rock and sediment. Half of it lies under the Yucatan Peninsula in Mexico, and the other half is submerged beneath the waters of the Gulf of Mexico. Its existence was only confirmed in the 1990s through geological surveys. Despite being hidden, scientists have mapped this crater in great detail using techniques like gravity and magnetic field surveys. These studies have revealed a large, complex impact structure. The main rim of the Chicxulub Crater is estimated to be about 180 kilometers or 110 miles in diameter. While this is enormous and represents one of the largest impacts in Earth's history, it is significantly smaller than the Vredefort Crater. If Vredefort is a giant's footprint, then Chicxulub is perhaps that of a very large but noticeably smaller beast. Its size is still difficult to comprehend, but it is clearly the runner-up in this contest of cosmic collisions. The asteroid that formed the Chicxulub Crater was also a huge object, estimated to be around 10 kilometers or 6 miles wide. It struck the Earth with unimaginable force. The location of the impact was particularly devastating. It hit a shallow sea rich in sulfur-bearing rocks. The impact instantly vaporized these rocks, blasting a colossal cloud of sulfur aerosols and soot into the stratosphere. This cloud would have spread around the globe, blocking out sunlight for years, leading to a prolonged and deadly impact winter. The planet would have been plunged into darkness and cold, causing plants to die and ecosystems to collapse worldwide. This is the event that scientists overwhelmingly agree caused the last mass extinction. It wasn't just the initial blast, but the long-term global climate chaos that followed. The dramatic and sudden environmental change was too much for many species to survive. The dinosaurs, which had dominated the planet for over 150 million years, were unable to cope with the collapse of their food chains. Along with them, about 75% of all species on Earth vanished forever. The Chicxulub impact was a reset button for life on Earth, a catastrophic event that ultimately cleared the way for the rise of the mammals, and eventually, us. So, we have two immense craters, Vredefort, the largest, at around 300 kilometers wide, and Chicxulub, the dinosaur killer, at a smaller 180 kilometers wide. Why is it that the smaller impact is blamed for such a famous extinction, while the largest one is not? The answer is simple and definitive: timing. The science of dating rocks is incredibly precise. By measuring the decay of radioactive elements in the rocks that were melted by the impacts, geologists can determine their age with great accuracy. This method is known as radiometric dating, and it provides a reliable clock for measuring deep time. The evidence is conclusive. The Vredefort impact, as we have seen, occurred approximately 2 billion years ago. This is an almost unimaginably long time ago. The dinosaurs did not even begin to appear on Earth until about 230 million years ago. Therefore, the Vredefort asteroid struck a world that the dinosaurs would not inhabit for another 1.77 billion years. It is simply impossible for this event to have caused their extinction. The world it impacted was a very different place, with a different atmosphere, and inhabited by very different, much simpler forms of life. Whatever its effects were, they had nothing to do with giant reptiles. In stark contrast, the Chicxulub impact is dated to precisely 66 million years ago. This date aligns perfectly with the fossil record. All over the world, in layers of rock dated to 66 million years ago, we see the sudden and complete disappearance of non-avian dinosaur fossils. Above this layer, there are none. Below it, they are abundant. This geological boundary, known as the Kapiki boundary, is also marked by a thin layer of clay rich in iridium, a rare element that is much more common in asteroids than in Earth's crust. This iridium layer is the global fingerprint of the Chicxulub asteroid, providing the crucial link between the impact and the extinction. And so the mystery is solved not by size, but by timing and evidence. Vredefort is the largest scar, a relic from Earth's deep past. Chicxulub, though smaller, was the killer. It struck at the right time and in the right place to trigger a global catastrophe that ended the reign of the dinosaurs. It is a powerful reminder that in the history of our planet, timing can be everything. These great craters are more than just holes in the ground. They are vital clues that help us piece together the extraordinary story of our world. Thank you for joining me on this journey through deep time. If you found this exploration of Earth's cosmic encounters fascinating, please do show your support. And for more stories from our remarkable planet, do consider following our channel.